Good morning, honorable present here. I am Nandini, working as an assistant professor in SNS College of Technology in the Department of Computer Science and Technology. Today we are going to see a role play with our students on the topic flow-based models.
So I am Anupriya. I play a role student in this role play. So flow-based model is a kind of generative AI model, and it transforms the simple probability distribution into a complex probability distribution. Is under the invertible transformation of reversible transformation. So it contains the possible solutions of lambda x and x power z. So it mainly focused on the invertible transformation of lambda power.
So what is meant by invertible transformation?
So invertible transformation is a reversible transformation that means that no information is lost in anything. For example, it contains the forward and backward movements of data transmission.
Yeah, what Anu said was correct. In flow-based models, data is mapped between two spaces, the latent space and the data space. In the latent space, it usually contains simple distributions like Gaussian distributions and the Gaussian noise. The transformations applied between the latent space and the data space are carefully designed that transformations applied between the latent space and the data space are both carefully designed so that the forward generation and the backward generations are efficient and exact. The bidirectional mapping is a key strength of this flow-based models.
Why this reversible transformation is much important?
Ma'am, it is to reconstruct the data and to compute the express between the data space and the latent space.
Yeah, correct.
I'm Priyanka, act as a student role. So the model typically starts with a simple distribution such as Gaussian distribution. This simple input is then passed through multiple transformation layer. Each layer gradually increases the complexity of the data until it resembles real-world structured data like images or audio. This step-by-step transformation process is what makes the model powerful and flexible.
So which distribution is commonly used nowadays?
Gaussian distribution is commonly used nowadays.
I'm Nitya. I am playing the role as student. In flow-based model, flow plays a major role. Flow refers as a sequence of invertible transformation applied one after the other. Each transformation in a flow is irreversible, and the multiple flows stack together to form a deep architecture. This deep architecture is moderately stacked together into a complex data distribution. Every transformation slightly modifies step by step, and because of this, the original data can be perfectly modified.
So why this flow is much important?
Flow is the basic structure of flow-based model, so which is invertible and which makes the original data more modified.
Myself, Monisha, the role-based student. An important concept in flow-based model is Jacobian determinant. It is used to measure the transformation that affects the probability density of a data. By calculating every step, the model can determine the exact likelihood of generated data. It is one of the advantages of approximate models in flow-based models.
So why this Jacobian is much important and what it will do?
It is used to calculate the probability changes in the flow-based model by using Jacobian determinant method.
So by this role play we can understand that how step by step this flow-based model is being used nowadays.
So in this flow-based model, it can be used with the major key components, that is latent space and latent variables, invertible transformation and reversible functions. In both the way, it can forward and backward movement to transform the data. So it can be used in many ways.
And in speech analysis, it is used to generate new patterns of speeches which are real, likely and realistic voices.
In anomaly detection, flow-based models are particularly effective because they assign probabilities to data points. Normal data will have high probability while unusual or abnormal data will have very low probability, making it easy to identify outliers.
So this flow-based model is very important for inversible transformation, and it can also fix complex data and simple data.